So I want to go over some calculator issues. I've seen them year after year after year. So here might be a good example problem. Milli, it should look lowercase, 10 to the what? And kilo. So on Alex, it's very important you put lowercase k in. So the first thing I do is I see kilo, and I'm going to put it down below. I don't really know how many milligrams in a kilogram. I could figure it out. But we have base unit of a gram and two different metric prefixes. So the most logical thing is to convert into the base unit first. So I like to put a 1 in front of the unit that has the metric prefix. And then you take what the prefix means and you put it up here. So now kilograms are going to cancel. I want to get rid of grams, and the question asks for milligrams. Then keeping with this convention, I put a 1 in front of the base unit that has the metric prefix, and then the base unit, I move that prefix down. And I could put the 1 times 10 to the third there. So I'm going to just go ahead and do this on my calculator, 0.0035 times 10 to the third, divide. Anybody get that number but the decimal in the wrong spot? You got that number but wrong decimal spot. Yeah, that's what we're here to fix today. So on my calculator, I put in this number. Then of course I go times, and then I hit the divide key, and then I hit enter. So a lot of times students like to do this. Let me just try that on my calculator and see what I get. Is that what you got? That's what you're getting. All right, so we want to figure out what's going on here. How many of you like orders of operations? Anybody can say the mnemonic? Why don't you sing it?
Pandas.
What?
You asked me to sing it.
The mnemonic for orders of operations.
Pandas. What are you talking about?
Parentheses. Like, what is it? Parentheses.
Exponent,
Guys.
multiplication, division, subtraction, addition.
Yeah, but there's something like my grandma, blah, 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 blah. Like,
Oh, please excuse my dear Aunt Sally.
that's it. That's what I wanted you to sing.
Okay. Please excuse my dear Aunt Sally. Oh my gosh, I better get extra points for that.
All right, very, very good. When you laugh, it helps you learn. So when you type into your calculator, let me get rid of all this. When you type this into your calculator, it ties it all together. And you don't have to put the times or anything in there. When you do this, it's going to go ahead and do that. And then when you hit the divide here, it puts that 1 in the bottom. And then when you multiply, it puts that up top. And so that's where you go wrong. If you want to do it that way, you're going to want to parenthesize that off. Because then it's going to do what's in the parentheses and then divide it. So I've said it before, I'm going to say it a billion more times. You need to get intimate with your calculator. Work through some of these issues, because I hate to see you get it all set up right, and then you type it in and the order of operations messes everything up. All right, any questions about orders of operations? And using the E key. So you don't have to go times when I enter a number. I just go 3.7, hit the E key, and that does it, and it ties it together. So here, mine got tied together and I got the right answer. The student, they didn't parenthesize that off, didn't tie it together, so it divided by 1, then multiplied when you really wanted to divide that. Good stuff. Any questions about Monday's lecture? So chemistry is the study of matter and the changes that matter undergoes. Classify matter by first asking this question: does the composition vary? So I like to ask this question. You go into Natural Grocer and you see this cheese there and it says 100% pure cheese. Is cheese a pure substance? Why not? Bunch of stuff in cheese. Right, there's low-fat cheese. Most cheese is high-fat, so the composition can vary. And I like to say, can you write a chemical formula for cheese? No, you can't. Can I write a chemical formula for water? Yes. Caffeine? Yes. So, pure substances have definite composition, and we can write a chemical formula. So cheese is a mixture. So we can classify mixtures as being homogeneous, like soft serve vanilla ice cream, or we can, because it's pretty uniform throughout. How would we classify Rocky Road ice cream? What's that? It's like nuts, caramel, delicious. So Rocky Road would be heterogeneous. Salt water would be a homogeneous sample. Concrete would be heterogeneous. Concrete's a mixture of lime, gravel, and all those things can vary. You can have different grades of concrete. Mixtures have variable composition. Pure substances do not. All right, so let's keep going with the pure substances. I said I can write a chemical formula for water. I can write a chemical formula for carbon dioxide. And people figured out something magical is going on because they always found the same percentage of hydrogen to oxygen. It didn't change. It had definite proportions. You always stick 2 atoms of hydrogen to 1 atom of oxygen. If for some reason there's another compound formed from hydrogen and oxygen called hydrogen peroxide, and it's going to have different amounts. But hydrogen peroxide, no matter where it's found or made, always has definite proportions of those 2 elements. All right, how many elements? So for all of these, have more than one, so we call them compounds. And compounds, here's a not too favorite one. Iron 3 oxide. It's not my favorite because I drive old vehicles and they seem to rust. Well, I'm driving a new vehicle right now, a 2019. But this sometimes gets mined and smelted down into iron. So via chemical methods, we can break down compounds. And oxygen exists as what we call a diatomic element. And we looked at nitrogen being a component of air, of course oxygen. Shortly, I'm going to tell you that these are molecular because they're formed from non-metals only. Things over on the right-hand side of the periodic table. Well, helium is over there on the right side, so is argon, and we could have some gold, some silver. Let's get good old mercury. Might as well throw in another heavy metal there. So carbon and oxygen are over there on the right, and we say that's a molecular compound. Water would also be. Now a good example of an ionic substance, sodium chloride. So we have a metal with a non-metal. 2 extremes of the periodic table. Sodium's over in that first column. Chlorine is second to the last column, right next to argon. So ionic substances you can spot by seeing a metal and a non-metal. Methane gas, CH4. Hydrogen's kind of a weird thing. We have it listed over there on top of the alkali metals. Some periodic tables draw it up in the middle. It can behave as a metal or a non-metal. We could draw it right in front of helium. So hydrogen's a bit of an exception, but for the most part, sulfur dioxide gas, we classify that as molecular because sulfur and oxygen are non-metals. This rust, how would you classify it? It's a compound. Is it ionic or molecular? Right, it's got to be ionic. You recognize iron being a metal. I've been telling you oxygen is a non-metal. Any questions on this flow chart? Noble gases would be atomic elements. But the nitrogen, oxygen, those elements that exist as diatomic compounds or elements, they're bonded together. You get chlorine would also be there, and fluorine gas as well. A lot of elements, we'll go over when we get to that point. Nonmetals exist as diatomic elements. When they're in their elemental form, meaning they're not hooked up with anything else, that's how we find them to be. So when you have a mixture, you ask yourself, is it uniform throughout? Yes. So here's looks like a shore on a sea, and you might see big rocks, sand, water, a big mixture going on. Multiple substances whose presence can be seen. Portions of a sample have different composition and properties. Solid sand, silicon dioxide, liquid H2O, hydrogen oxide. And maybe this is a big thing here, seen. Because here it looks like tea, and some people put a lot of sugar in their tea, some people don't, so the composition can vary. Made of multiple substances, but appears to be one substance, meaning it's uniform throughout, it's the same color throughout, has the same density throughout. All portions of the sample have the same composition and properties. Like if I took a gram out of the top and analyzed it for carbon, oxygen, I'd get some percentage, and if I took the last teaspoon out, I'd get the same composition. So all matter can be classified on this table here. We have pure substances. So you go to the grocery store and it tells you this food item is pure. That means hopefully there's no perspiration, hair, insecticides, shards of glass, all that great stuff. But in chemistry class, pure substances means has definite composition, and you can probably write a chemical formula for it, meaning elements and compounds. So here it looks like we got copper, sugar, roughly, and then here mixtures, back to our English tea. You can see caffeine, sugar, a bunch of water, and all the things that give the tea that color and flavor. They didn't draw, but a bunch of stuff. So here we see our Italian dressing, olive oil and water, and there's the oil made from just carbon and hydrogen, a hydrocarbon, and there's the water, and they don't like to mix, and you look at that and it doesn't look very uniform. And the top part is a different color than the bottom part. And the top part has different properties than the bottom part. Questions? All right, that will do it for today.